as you can imagine, drawing tangent and cotangent functions in a computer is kind of tough. So we do the next best thing, which is we draw the function for you, and you tell us what the equation was that produced this graph. It's actually not more difficult than drawing the function, but it is a lot easier to enter into a computer, so we're going to use that. And what we need to write the function is 4 parts of a graph. We need the vertical scaling factor, we need the horizontal scaling factor, we need the phase shift, and we need the midline. So we're going to figure out what each of these things is from our picture, and then we're going to build the equation like that, okay? So the very first thing I want to do is talk about asymptotes. That's where everything gets started here. The asymptotes are these forbidden domain regions. These are the domain restrictions of your function. And they're the same whether or not you think of this as a tangent or a cotangent function. You can just look at the graph and say, yeah, there's vertical lines. The function is obviously trying hard to avoid touching. See, it's going vertical right here. It's not going to touch that asymptote that I just drew. So where are the asymptotes located? We need to figure that out. So let's talk about this one on the right. And we'll get to the one on the left later. So I'm going to take the average of these 2 points. Halfway in between pi and 3 pi over 2 is described like this. Halfway in between their sum. Pi plus 3 pi over 2. Now, pi plus 3 pi over 2, if you think about fractions, this is 2 pi over 2 on the left. So that's going to be 1/2 times 5 pi over 2. You're going to get plenty of practice adding fractions in this unit. And that's going to be 5 pi over 4. Okay, so that's the x location of the asymptote on the right. Now we do the same thing for the x location of the asymptote on the left. Think what's halfway in between pi, negative pi, and negative pi over 2. Well, a little faster this time. 1/2 of negative pi plus negative pi over 2 is just going to be 1/2 of negative 3 pi over 2, which is negative 3 pi over 4. Okay, so now what's the distance between these 2 points? Negative 3 pi over 4 and 5 pi over 4. That's going to tell us something about the period. Or what's halfway in between those 2 points. That's going to tell us something about the midline. Let's actually do the midline first. I want to talk about this imaginary line. This is not an asymptote. It's not very well drawn either. Come on. Give me this thing back. Here we go. Halfway in between those 2 asymptotes, you're going to have a midline crossing right here. Okay, so I don't need this green line. But that point right there is where the midline is located. The midline, if you remember, is a y equals equation. It's the halfway point, vertically speaking, of your function. So you can see that crosses negative 3. So that tells me one nice thing, k equals negative 3. Okay, we're going to use that. I also know that halfway in between the midline crossing, I'll label this like I do in some of the other problems. This is point C. Okay, and here's asymptote E over here on the right side. Halfway in between C and E is D. So you can just label that on your graph right there. There's my D point. And likewise, if you go in the other direction, we have point B right here. And we have asymptote A up on the left. And I need to clear some of the junk out of the way. So hold on. There we go. So these A, B, C, D, E points define your function's basic properties. And we're going to start with, well, we already did the midline. So let's start talking about D and B. The distance from C down to D, or the distance from C up to B, is your vertical scaling factor. So in this case, you can see that's a height of 2. So that means my A factor, the vertical scaling, is 2. Okay? And now we should talk about period. What is the width of this function? We mentioned that before. Right? The width between these 2 asymptotes is going to be the period, which, it's unfortunate I erased one of these guys. Let's try to remember, what was it? Negative 3 pi over 4. Some people make the mistake, and this is pretty common actually, they make the mistake of saying, 5 pi over 4, the right asymptote is my period. Well, it's not. The period is the distance between those 2 asymptotes. So here's how you figure out the period graphically. You say the period equals my point on the right, 5 pi over 4, minus the point on the left. Think of it like a ruler. It works the same way. 5 pi over 4 minus negative 3 pi over 4, which is going to be equal to 8 pi over 4, which equals 2 pi. Okay, that's nice, but it doesn't tell us anything for this equation. You have to take one more step. I'm going to move over here, please. Period equals 2 pi. Well, that's equal to pi over b. If you remember that very important equation. And now we can just divide each side by pi, multiply each side by b, we get 2b equals 1. Divide each side by 2, we get b equals 1/2. Okay, so there's another one of our 4 important variables. What's missing? H. Great, h is easy. For a cotangent function, remember that's what I'm dealing with here. I'm dealing with cotangent. You just describe the x location of the left asymptote, a, and that is negative 3 pi over 4. Okay, so h equals negative 3 pi over 4. Now we're going to take these guys and just plug them into an equation. So according to the general format right here, I'm going to write it the same way. F of x equals a, which is 2, times cotangent, times b, which is 1/2, that's the horizontal scaling factor, x minus negative 3 pi over 4, which is going to be x plus 3 pi over 4. And there's your midline. Okay, so that is our answer. That's this graph in terms of a cotangent function. Now remember, it asked for tangent function too, which is not as convenient because this graph goes from top left to lower right. It's an upside down version of a tangent function. So what you have to remember when you're writing the tangent function is you have to add a negative to that vertical scaling factor right there. There's going to be one more change, but a lot of these things we can keep the same. Okay, see, I kept the midline the same, I kept the scaling factor the same, I just changed its sign. B is the same because the period hasn't changed, but the phase shift has changed. In a tangent function, this is your phase shift. Okay, I'm going to write that right here. Tangent phase shift. That is the middle point, whereas the cotangent phase shift is over here, the left side. Cotangent phase shift. Of course, any asymptote would do for cotangent, but I usually pick the left one. So what's the midpoint? That's, did we ever talk about that one? Well, it's halfway between these 2 points, 5 pi over 4 and negative 3 pi over 4. So halfway in between those is half of negative 3 pi over 4 plus 5 pi over 4, which is 1/2 of 2 pi over 4, which is just going to be pi over 4. Okay, so that is our phase shift, which we write this way. Don't forget that sign flip. Okay, and we're done.